What is Ethereum and how does it work? By the end of this video, you'll understand everything about Ethereum, even if you are a complete beginner. Most people have heard of Ethereum, but even among those who own it, only few truly grasp how it works or why it's revolutionary. So understanding fundamentals of number 2 cryptocurrency can create you a huge advantage and opportunities for reaching financial freedom. As Ethereum continues to evolve, the gap between those who understand it and those who don't will only widen. So if you're serious about reaching financial freedom within the crypto space, make sure to subscribe to Bitcoin Academy. I am Bitcoin Professor, and I was designed to teach you about world of cryptocurrencies. And the best part, I am doing it for free. Today, we're going back to basics. We'll explain Ethereum in plain terms, what it is, how it works, and why it's more than just Bitcoin's smarter cousin. By the time we're done, terms like smart contracts, gas fees, DeFi, and proof of stake will make perfect sense. And if you're completely new to crypto, no worries, there's a free Learn Crypto in 24 Minutes course on our channel. Links in the description. Before we dive in, let's divide this video into 8 key topics. Number 1, what Ethereum solves. Number 2, comparing Ethereum and Bitcoin. Number 3, smart contracts explained. Number 4, gas fees and how transactions work. Number 5, proof of stake. Number 6, DeFi and DAPPs. Number 7, Ethereum's biggest challenges. Number 8, the future of Ethereum. And we will finish this video with my personal take, as we always do. Let's start with topic number 1, which is why Ethereum exists in the first place. To understand why Ethereum exists, we need to first look at what Bitcoin could not do. Bitcoin was created as digital cash, a way to send money without the middleman, which are banks. It does this job perfectly. But imagine if your smartphone could only make calls and send texts. You wouldn't be able to use apps, browse the internet, or take photos. That was the state of blockchain technology before Ethereum came along. Bitcoin's blockchain is like a notebook that only records money transfers and inscriptions, but that is a topic for another video. Alice sends Bob 1 BTC. End of story. It pretty much can't handle anything more complex. This limitation exists by design. Bitcoin keeps things simple to stay secure and fully decentralized. But this simplicity means it can't create contracts, build applications, or automate agreements. The world needed a blockchain that could do more than just payments. This is where Ethereum comes in. Created by Vitalik Buterin in 2015, Ethereum was designed as a programmable blockchain. Think of it like a computer that runs on a global network instead of a single machine. While Bitcoin handles money, Ethereum handles money plus logic. It can execute what we call smart contracts, which are self-operating agreements written in code. Let me give you a real-world example. Imagine renting an apartment. Normally, you'd need to sign a lease, pay a security deposit, and trust the landlord to return it when you leave. With Ethereum, you could create a smart contract that automatically holds your deposit and releases it back to you when your rental period ends, if all conditions are met. No need to trust or chase anyone. The code handles it. This simple idea opened up endless possibilities. For the first time, developers could build entire applications that run on blockchain. These aren't like normal apps that live on Apple's or Google's servers. They run on Ethereum's decentralized network, meaning no single company controls them or can interfere with them. This created entirely new categories like decentralized finance, where you can borrow, lend, and trade without banks, and NFTs, which serve as proof of ownership for digital items. Before Ethereum, if you wanted financial service online, you needed to work through banks and government payment processors. Now, developers can build these services directly on Ethereum. A lending app can connect borrowers and lenders worldwide without a bank in the middle. An artist can sell digital artwork directly to collectors with automatic royalty payments built in. The key innovation was making blockchain programmable. Bitcoin gave us digital money that doesn't require trust in banks. Ethereum took this further by giving us digital agreements that don't require trust in any middleman. This is why Ethereum has become the foundation for an entire ecosystem of applications that are changing how we interact with money, contracts, and even online identity. To put it simply, if Bitcoin is like email, a way to send messages directly without going through the post office, then Ethereum is like the entire internet built on top of email. It's not just a tool, but a platform for building new tools. This is why Ethereum has grown to become the second largest cryptocurrency, and that is why understanding it gives you such an advantage in the crypto space. In our next topic, we'll compare Ethereum and Bitcoin directly, so you can see exactly how they differ in their design and purpose. But already, you can see why the world needed more than just Bitcoin. we needed a blockchain that could do more than just send money from point A to point B. Topic number 2, comparing Bitcoin and Ethereum. Now that we understand why Ethereum was created, let's compare it directly to Bitcoin. Many beginners think they're just two versions of the same thing, but that's like comparing a bicycle to a motorcycle. Both get you from point A to point B, but one can do much more. And if you want to understand how Bitcoin works, make sure to check this video on our channel. It will give you everything you need in order to understand father of crypto, which is Bitcoin. I will leave a link down in description. All right, let's break it down into 3 key areas: transactions, security, and flexibility. First, transactions. On Bitcoin, a transaction is simple. It's just a record of someone sending Bitcoin to someone else. That's it. On Ethereum, a transaction can be much more complex. It could involve executing a smart contract, minting an NFT, or interacting with a decentralized app. This is why Ethereum transactions require more data and often cost more in fees, which we'll cover in topic 4. Second, security. Bitcoin uses a system called proof of work, where miners solve complex math problems to validate transactions. This makes Bitcoin extremely secure but uses a lot of energy. Ethereum used to work the same way, but recently switched to proof of stake, where validators lock up Ethereum to secure the network. This reduced Ethereum's energy use by 99%, which we'll explore in topic 5. Third, flexibility. Bitcoin's scripting language is intentionally limited to keep it secure and simple. Ethereum's programming language is much more flexible, allowing developers to build almost any application they can imagine. This flexibility is why Ethereum has become home to decentralized finance, NFTs, and thousands of other applications. Here's a real-world example to show the difference. Imagine you want to send money to a friend overseas. With Bitcoin, you can send the money directly, without a bank. That's great. But what if you want to add conditions? Maybe you only want the money sent if your friend arrives safely, or you want to split it between multiple people automatically. Bitcoin can't do that. Ethereum can, through smart contracts. Another big difference is speed. Bitcoin processes about 7 transactions per second. Ethereum currently handles about 30, though upcoming upgrades aim to increase this significantly. This might not sound like much compared to XRP's 1,500 transactions per second. But remember, these are global networks that don't rely on any central authority. The communities behind each project also have different philosophies. Bitcoiners tend to prioritize security and decentralization above all else. The Ethereum community is more willing to make changes and upgrades to enable new features. This is why Ethereum evolves faster, though some argue this makes it less stable than Bitcoin. To summarize, Bitcoin is like digital gold, a store of value and medium of exchange. Ethereum is like digital oil, powering a vast ecosystem of applications. Bitcoin is the more conservative, stable option. Ethereum is the more experimental, flexible platform. Understanding this difference is crucial because it affects how you might use each one. If you just want an alternative to traditional money, Bitcoin might be enough. But if you want to explore decentralized apps, smart contracts, or the future of finance, you'll need Ethereum. In our next topic, we'll dive into smart contracts, the revolutionary feature that makes all of Ethereum's advanced functionality possible. This is where things get really interesting, because smart contracts are what turn Ethereum from just a cryptocurrency into an entire programmable economy. Topic number 3, explaining smart contracts. Smart contracts are what make Ethereum special. They're not just a feature, they're the foundation of everything Ethereum does. But what exactly are they? Let me explain it in the simplest way possible. A smart contract is like a vending machine for agreements. You put in your money, select what you want, and the machine automatically gives it to you. No cashier needed, no trust required. The rules are built into the machine itself. That's exactly how smart contracts work on Ethereum, except they can handle much more than just snacks. Here's how they work in practice. A smart contract is a set of instructions written in code that lives on the Ethereum blockchain. Once deployed, it runs exactly as programmed. No one can change it, stop it, or interfere with it. The contract executes automatically when certain conditions are met. Let's look at a concrete example. Imagine you're buying a house. Normally, you'd need lawyers, banks, and escrow services to handle the transaction. With a smart contract, you could program the entire process in 3 steps. Here is an example. Step number 1, the buyer deposits the purchase amount into the contract. Step number 2, the seller provides digital proof of ownership. Step number 3, when both conditions are met, the contract automatically transfers the money to the seller and the ownership to the buyer. No banks taking days to process the transaction. No lawyers charging fees. No risk of either party backing out. The contract handles everything automatically based on the rules written into its code. This might sound simple, but the implications are enormous. Smart contracts eliminate the need for middlemen in all kinds of transactions. Here are some examples that you might be familiar with of what smart contracts can do. Number 1, automate insurance payouts when flight delays occur. Number 2, manage supply chains by releasing payments when goods arrive. Number 3, create decentralized organizations that run without CEOs. Number 4, handle payroll by paying employees exactly when they complete work. You don't need to trust the other party. You just need to trust that the code will execute as written. And since the code is public on the blockchain, anyone can verify how it works. This technology has already created trillion-dollar industries. Decentralized finance or DeFi platforms use smart contracts to recreate banking services without banks. NFT marketplaces use them to handle digital ownership. Even traditional companies are starting to use them for things like royalty payments and supply chain management. Let me explain one example I like to use when people ask me about NFTs. You know about luxury watch company called Rolex. Well, Rolex has huge problems with copies being made all around the world, which damages their revenue and image. Now imagine if Rolex just created one smart contract for every series of Rolexes being made, and each watch gets correlating NFT. So you buy watch and you receive NFT, which stores all information proving that that watch is original. Then when you want to resell it, buyer receives that NFT along with the Rolex watch. And boom, no more possibility for fake Rolex to pass as original, because it is impossible to interfere with their smart contract. One more thing that makes Ethereum's smart contracts special is that they're composable. This means different contracts can work together like Lego blocks. Developers can build on top of existing contracts to create complex systems. This composability is why Ethereum has become the foundation for so many applications. Of course, smart contracts aren't perfect. If there's a bug in the code, bad things can happen. And since contracts can't access real-world data on their own, they need something called oracles to feed them information, which introduces some form of centralization, which is against crypto philosophy, but it is necessary in order to create complex systems on blockchain. But despite these challenges, smart contracts represent a fundamental shift in how we make agreements. They're creating a world where business logic can be automated, where intermediaries become optional, and where trust is established through code rather than institutions. In our next topic, we'll look at gas fees, which are the cost of running these smart contracts and transactions on Ethereum. Because while smart contracts are powerful, they're not free to use. And understanding how gas fees work is crucial for anyone using Ethereum. Topic number 4, how gas fees and transactions work. If you've ever tried using Ethereum, you've probably noticed that every transaction costs something. This isn't arbitrary. There are important reasons why Ethereum can't be completely free to use. Think of gas fees like the fuel that keeps Ethereum running. Just like your car needs gasoline to drive, every operation on Ethereum requires gas to execute. This includes sending ETH, interacting with smart contracts, or interacting with NFTs. The more complex the operation, the more gas it requires. Here's how it works in practice. When you want to make a transaction on Ethereum, you specify 2 things: the gas limit, which is how much computational work you're willing to pay for; the gas price, which is how much you're willing to pay per unit of gas. The total fee is gas limit multiplied by gas price. And don't let it scare you if you don't understand it, because this process is done automatically. And unless you are looking to become a blockchain developer, you will never need to do this manually. But the more you know and understand, the better. This system serves 3 crucial purposes. First, it prevents network spam. Without fees, someone could flood Ethereum with meaningless transactions and crash the network. Fees ensure that only serious and important transactions get processed. Second, it compensates validators. These are the people who run Ethereum's infrastructure and verify transactions. Gas fees are their incentive to keep the network secure and operational. Third, it allocates resources fairly. When the network is busy, users who need their transactions processed quickly can pay higher fees to jump the queue. Let me give you a real-world comparison. Imagine Ethereum is a highway and transactions are cars. Gas fees are like tolls. When the highway is empty, tolls are cheap, but during rush hour, tolls increase to manage traffic. Some drivers who pay higher tolls get to use the express lanes. Or just think about private jets. You pay much more money than regular airline ticket costs. But in return, you save so much time. The price of gas isn't fixed. It changes based on network demand. During peak times like NFT drops or major DeFi launches, gas fees can spike dramatically. We've seen times when simple transactions cost over $100 in fees. This is one of Ethereum's biggest challenges that its developers are working to solve. There are some important differences between how Bitcoin and Ethereum handle fees. Bitcoin fees are based solely on transaction size in bytes value. Ethereum fees are based on computational complexity. A simple Ethereum transfer might use 21,000 gas units. A complex DeFi transaction could require 500,000 plus gas units. This is why Ethereum transactions can sometimes cost more than Bitcoin transactions. They're often doing much more work behind the scenes. Here's a practical tip for new users. If your transaction isn't urgent, you can set a lower gas price and wait for network activity to decrease. Wallets like MetaMask often suggest appropriate gas prices based on current conditions. And once again, make sure to check our 24-minute course for crypto beginners, which will even teach you how to create MetaMask wallet in few simple steps. It costs nothing. Looking ahead, Ethereum's upcoming upgrades aim to make gas fees more predictable and affordable, but the fundamental principle will remain. Using Ethereum's global computer will always have some cost, because maintaining a decentralized network isn't free. In our next topic, we'll explore how Ethereum recently transformed its security model with proof of stake, cutting its energy use by 99% in what's been called one of the most ambitious upgrades in crypto history. Topic number 5, proof of stake. Ethereum recently underwent one of the most significant changes in crypto history. In September 2022, after years of development, Ethereum successfully transitioned from proof of work to proof of stake. This wasn't just a small upgrade, it completely transformed how Ethereum operates while solving one of its biggest criticisms, which is energy consumption. Let's start by understanding what proof of stake actually means. Under the old proof of work system that Bitcoin still uses, miners competed to solve complex math problems to validate transactions. This required massive amounts of electricity. At its peak, Ethereum was using as much energy as a small country. Proof of stake changes this dramatically. Instead of miners, we now have validators. These validators don't solve math problems, they simply lock up or stake their Ethereum to participate in securing the network. The more Ethereum you stake, the higher your chances of being chosen to validate transactions and earn rewards. Here's how it works in practice. First, to become a validator, you need to stake at least 32 Ethereum. This is like putting down a security deposit that proves your eligibility. Second, validators are randomly selected to propose new blocks of transactions. The selection isn't completely random. Those who stake more Ethereum have better odds, but there's always an element of chance. Third, other validators verify the proposed block. If enough agree it's valid, the block gets added to the blockchain and the validator receives a reward. Fourth, if a validator tries to cheat or approve fraudulent transactions, they can lose part or all of their staked Ethereum. This is called slashing, and it's what keeps validators honest. The benefits of this system are enormous. First, energy efficiency. Proof of stake reduced Ethereum's energy consumption by over 99%. Validating transactions now uses about the same energy as a large home computer rather than an industrial mining operation. Second, accessibility. Under proof of work, mining required expensive specialized hardware. Now, anyone with 32 Ethereum can participate in securing the network. Third, security. The economic incentives make attacking the network extremely costly. To manipulate transactions, you'd need to control at least 51% of all staked Ethereum, an amount that would cost enormous amount of dollars to acquire. Fourth, scalability. Proof of stake lays the foundation for future upgrades that will help Ethereum handle more transactions per second. Let me give you a real-world comparison. Proof of work is like a lottery where everyone buys tickets by solving math problems, which burns energy. Proof of stake is like a lottery where your chances depend on how much money you're willing to lock up as collateral, which uses minimal energy. There are some concerns worth mentioning. First, proof of stake favors those with more Ethereum, potentially leading to centralization among large holders. Second, the 32 Ethereum requirement makes it difficult for average users to participate directly. Third, the system is still relatively new compared to Bitcoin's battle-tested proof of work. Despite these concerns, the transition has been remarkably smooth. Today, over 26 million Ethereum, which is worth tens of billions of dollars, is staked, securing the network. The environmental benefits alone make this one of the most important developments in crypto history. Looking ahead, proof of stake enables further upgrades to Ethereum's architecture which we'll explore in our final topics. But first, in our next section, we'll examine how all these technical foundations support Ethereum's most exciting use cases, the trillion-dollar world of decentralized finance and applications. Topic number 6, decentralized finance and decentralized applications. Now we arrive at the most exciting part of Ethereum, the real-world applications that are transforming finance and the internet as we know it. These aren't just theoretical concepts anymore. Today, there's an entire parallel financial system running on Ethereum that handles billions of dollars every day, all without banks or traditional institutions. Let's start with decentralized finance, or DeFi. Imagine being able to borrow money, earn interest, or trade assets without ever dealing with a bank. That's exactly what DeFi makes possible. Here's how it works. Instead of banks holding your money and controlling transactions, smart contracts create financial services that anyone in the world can access. You interact directly with the code through your crypto wallet. No account applications, no credit checks, no business hours. Some of the most popular DeFi applications include decentralized exchanges that let you trade crypto without signing up for an account. These platforms have processed over $1 trillion in trades. Lending protocols where you can earn interest by depositing crypto, often at rates much higher than traditional banks offer. Stable coins, which are cryptocurrencies pegged to real-world assets like the US dollar that provide stability in the volatile crypto market. Insurance platforms that protect against smart contract failures or exchange hacks. All of these services run 24/7, with transactions settling in minutes rather than days. And they're available to anyone with an internet connection, regardless of location or banking status. Now let's talk about decentralized applications, or DApps. These are like normal apps you use every day, but with one crucial difference. They run on Ethereum's blockchain instead of company servers. This means no single entity controls them. They can't be censored or shut down. They often have built-in payment systems using cryptocurrency. Some groundbreaking DApps include marketplaces for digital art and collectibles that have generated billions in sales, decentralized social media platforms where users control their data and earn rewards for participation, gaming platforms where players truly own their in-game items as NFTs that can be bought and sold, supply chain tracking systems that provide transparent records of product origins. The numbers behind this ecosystem are staggering. At its peak, the total value locked in DeFi protocols exceeded $150 billion. Popular dApps routinely handle millions of users and billions in transactions. And this is just the beginning. What makes Ethereum so powerful for these applications is composability, the ability for different smart contracts to work together seamlessly. Developers can mix and match existing protocols like financial Lego blocks to create new services. An application might combine a lending protocol, decentralized exchange, and yield aggregator to offer sophisticated financial products that would be impossible in traditional finance. Of course, this new frontier comes with risks. Smart contract bugs have led to hundreds of millions in losses. Scam projects abound in the unregulated space, and the complexity can be daunting for newcomers. But the potential is undeniable. Ethereum is enabling new business models for creators and internet services that put users in control. As the technology matures and becomes more user-friendly, we're likely to see even more innovative applications emerge. In our next topic, we'll examine the challenges Ethereum faces as it grows, from technical limitations to regulatory uncertainty. Because while the potential is enormous, the path forward isn't without obstacles. Which bring us to topic number 7, Ethereum's biggest challenges. For all its revolutionary potential, Ethereum faces significant hurdles that could determine its long-term success. Let's examine the 3 biggest challenges standing between Ethereum and mass adoption. First challenge is scalability issues. Ethereum currently processes about 30 transactions per second. Compare that to XRP's 1,500, and you see the problem. During peak times, the network becomes congested, sending gas fees skyrocketing to hundreds of dollars per transaction. This makes simple interactions prohibitively expensive for regular users. The Ethereum team is working on solutions through upgrades like sharding, which is splitting the network into smaller pieces, Layer 2 solutions, which are secondary networks that batch transactions, and continued optimizations to the base layer. But these fixes take time, and until they're fully implemented, Ethereum struggles with its own success. When applications go viral, they often become unusable due to network congestion. Second challenge is rising competition. Other blockchains have emerged promising faster speeds and lower fees. Solana boasts 65,000 transactions per second, and our next video will be explaining Solana. So once again, make sure to subscribe if you don't want to miss it. Avalanche offers sub-second finality. Even Bitcoin is getting smart contract capabilities through Layers 2 options like stacks. These competitors have attracted developers and users with near-instant transactions, fees costing fractions of a penny, and developer-friendly environments. While Ethereum still dominates in total value locked in developer activity, the competition is forcing rapid innovation. The risk is fragmentation, where no single blockchain achieves critical mass because users are spread too thin across dozens of networks. Third challenge is regulatory uncertainty. Governments worldwide are scrambling to understand and regulate decentralized finance. Key concerns include tax compliance for DeFi transactions, consumer protection against scams and hacks, anti-money laundering enforcement. The biggest threat is the potential classification of Ethereum as a security rather than a commodity. This could subject it to much stricter regulations that might limit who can buy and trade Ethereum, force changes to how staking works, create compliance burdens for developers. Recent actions against crypto companies suggest regulators are taking a harder line. How Ethereum navigates this landscape will significantly impact its future. Additional challenges worth noting. User experience remains too technical for mainstream adoption. Environmental concerns persist despite proof-of-stake transition. Centralization risks in staking pools and Layer 2 solutions. The path forward isn't easy, but Ethereum's strong developer community and first-mover advantage give it a fighting chance. Upcoming upgrades aim to address many of these issues, which we'll explore in our final topic about Ethereum's future. What's clear is that solving these challenges will require balancing three competing priorities: maintaining decentralization, the core ethos of crypto, achieving scalability in order to support mass adoption, and ensuring security in order to protect billions in value. In our final section, we'll look at Ethereum's roadmap and why many believe its best days are still ahead. The solutions to these challenges could determine not just Ethereum's future, but the future of the entire blockchain industry. Topic number 8, the future of Ethereum. Ethereum stands at a crossroads. It has already revolutionized blockchain technology, but its greatest achievements may still lie ahead. The next few years will determine whether Ethereum becomes the foundation for a new internet and financial system or gets overtaken by faster, more efficient competitors. So what does the future hold? Let's break it down into three key areas: upgrades, adoption, and long-term potential. First, upgrades. Ethereum's development roadmap, known as Ethereum 2.0 or the merge, which already happened, was just the beginning. The next major phases include danksharding, a scaling solution that will split Ethereum into smaller chains, increasing transaction capacity exponentially. Proposer-builder separation, or PBS, which aims to reduce centralization risks in block production. Account abstraction, making wallets smarter and more user-friendly, so interacting with Ethereum feels as simple as using a regular app. These upgrades could finally solve Ethereum's scalability issues, bringing fees down to cents instead of dollars and supporting millions of users seamlessly. Second, adoption. Ethereum's real-world use is growing faster than ever. Major companies like Visa and PayPal are experimenting with Ethereum-based settlements. Governments are exploring central bank digital currencies, or CBDCs, built on Ethereum's tech. Even traditional finance is embracing DeFi, with institutions using Ethereum for everything from bond issuance to derivatives trading. But the most exciting adoption is happening at the grassroots level. Artists, gamers, and entrepreneurs are building entirely new economies on Ethereum. Imagine a future where your social media profile is an NFT owned by you and portable across platforms. Your paycheck arrives via a smart contract instantly and without bank delays. You borrow money against your crypto holdings without credit checks or paperwork. This isn't science fiction. It's already happening in early forms today. Third, long-term potential. Ethereum's ultimate goal is to become a world computer, a decentralized backbone for the next generation of the internet. If successful, it could replace today's tech giants with open protocols where users control their data, identity, and finances. But success isn't guaranteed. Ethereum must overcome its challenges while staying true to its decentralized roots. The next few years will be critical. If upgrades roll out smoothly, adoption could explode. If delays or regulatory crackdowns happen, competitors might gain ground. And let's finish this video with my personal take. Despite Ethereum's growth, we're still in the early stages. Less than 1% of the global population actively uses DeFi or DApps. Institutional investment is just starting, And most of Ethereum's killer apps probably haven't even been invented yet. So just understanding 30% of this video puts you in front of so many people today. Crypto world is reshaping the world we know. There is no doubt about it. And trust me when I say, you want to be included in it early. You might ask why, but the answer is simple. Competition is super low right now, and true mass adoption is still yet to come. Think of Ethereum like the internet in the 1990s. The infrastructure was clunky, but the potential was obvious. Those who understood it early had a massive advantage. The same is true for Ethereum today. I truly hope you understood today's video and you found it valuable. And if you did, don't forget to like the video and subscribe to Bitcoin Academy. Also, feel free to leave a comment on which video topic you would love to see next, and I will do everything in my power to make it.